Thank you for joining this lesson, Current Electricity 2. Study the circuit diagram below and answer the questions that follow. So we have a circuit diagram here. We have a resistor of 1 ohm, 2 ohms, 4 ohms. Then we are also having a battery here, or cells, with a total voltage of 12 volts and an ammeter here to record the current. The first question, calculate the current flowing through the ammeter. For us to calculate current according to Ohm's law, we should know that V equals to IR. So for us to get current, then we will need V out of R. This means we have to get the effective resistance in this connection. We'll start by the two resistors which are parallel to one another, and for us to get the effective resistance in this and this resistor, we will need their product divided by their sum. When they are two and in parallel, this is how we get effective resistance. So we need 2 by 4 divided by 2 plus 4, and that gives us 8 out of 6. So 8 over 6, this will give us 1.33 recurring ohms. Then in series, now this can be substituted by one resistor of 1.33. So we are having 1 and 1.33 in series. That means total effective resistance now. Total resistance will be resistor 1 plus resistor 2. In series, we just add it into resistances. So the first one is 1 plus the second one, in which we are saying the effective for these two is 1.33. So this gives us a 2.33 ohms. That is the effective resistance. So for us now to get current, we need voltage of 12 divided by total resistance of 2.33. This will take us to a value, which is, when I had 1 here, then I take 12 divided by this answer, I'm getting 5.14. 5.14 amperes. That is now the current. Something else we are told to calculate is the potential difference across AB. Potential difference across AB. So what we call potential difference is the voltage, and remember it will be given by IR. At AB, or across AB, we already know the resistance. What remains is the current at that point. And remember, we can first use the first resistance here to know the current through it. So the current through the 1 ohm resistor, current is given by current there, because it is in series with the cells. The total current will pass through this junction, and the total current is already calculated here as 5.14 amperes. Yes. So the same current is going to proceed. The same current is going to proceed to this junction, but it will get split. Now, as it gets split, we need to know the voltage here, so that we know the balance of the voltage that proceeds to this junction. Therefore, with current and resistance, we can get voltage here. So voltage in the 1 ohm resistor is given by current times the resistance of 5.14 volts. This is the voltage across the 1 ohm resistor. That means voltage which proceeds now to the junction here, and because the junction has parallel resistors, then the voltage will be the same in the 2 ohm resistor and the 4 ohm resistor. So voltage across AB is going to be 12 minus 5.14, because this is now the total voltage that will proceed to the junction. 12 minus, this gives us 6.5, this is 86 volts. So this is the voltage which proceeds to AB. It should also be noted that it is also the same voltage across the 4 ohm resistor. Finally, we are also told to calculate the current through the 4 ohm resistor. Through the 4 ohm resistor, we are saying that voltage will be the same as through AB, and that is 6.86. So with voltage and resistance, we can get current. So current through the 4 ohm resistor, current is usually given by voltage out of resistance. The voltage in the 4 ohm resistor is 6.86, owing to the fact that it is parallel to the region AB, and we have the voltage there. It is going to be the same. The resistance is already known to be 4. Therefore, when we divide this by 4, we are getting a current of 1.71 amperes. So this is the voltage that will be across that resistor.